So confused how to get 1014 into 9.5514.1. You aside from what I just explained, like this will be part of your test case. You'll set your current location. You don't get this from the path at all. You have a path and a location, and you have to determine what direction to move in at velocity 5. Sounds like there was a 199 exam, so I'm not interested in that. So let's get to some slides. Testing actors. Ooh, boy. What's up, RT Keenan? Where is my mouse? Oh, everything's out of whack right now. I was recording 199 lectures, so everything's just, and I moved everything around for that. So everything's just a little bit off of where I usually have them. Which was true Monday too, but apparently that didn't matter. What did I get in 199? I got an A. Don't doubt me. 199 was different when I took it too. I thought it was, I'm not getting into it. They cover a little bit more content now. When I took it, I thought it was pretty watered down. That course got pretty weak. And now they have a little more meat in that class, which is exciting. But yeah, I got two A pluses. Don't doubt me. So let's talk about how to test actors. Actor test sounds really complicated, and it kind of is. It's a new way of thinking. So as we'll see in this lecture, we have to do testing when time is a factor. So how do we test things when, one, things can be happening in any order? How do we control that order and test properly? And two, how do we manage time? It's not enough to just say, run this method and then see if the value is what I expect. Now you have to do some things, wait some certain amount of time, and then test things at the appropriate time. As you'll see in spades in the clicker assignment, clicker has, if you haven't played a clicker game, you have equipment that you can buy, which has passive income, without getting into too many details right now because I want to get through these slides. But you'll have passive income. So for each, as time is passing, you're incrementing values. So for your testing in clicker, there are a lot of tests where you'll buy some equipment, wait 1 second, and then make sure that they generated the income that you expect after 1 second of idle income. So we have time being a factor. That's what we're leading up to. Time is a factor. How do we handle that in our testing? So let's talk about testing actors. For this, we're going to have a pretty simple actor for our lecture question, and of course with a lot of setup, but most of this isn't too difficult. The difficulty of this lecture question is, of course, in the testing. How do we test the functionality that we're given? So for this, we're going to create a bank actor, which is going to track a value, which is the amount of money in this bank account. We can get deposit, withdrawal, and check balance messages. And when we get a check balance message, we're going to return a balance message with the current amount of money that's in this bank account. So the bank account, and this is all int values. We're not worrying about doubles either here. So the bank account starts with 0 funds. Whenever you get a deposit, add the int from that deposit to the current funds of the bank account. Whenever you get a withdrawal, you're going to subtract those funds from the bank account, but only if you have enough funds to withdraw. If this would cause an overdraft where the withdrawal is greater than the current funds in the bank account, don't do anything. Don't drain the entire account to 0 and do a partial withdrawal. Just don't do anything. If you can't meet the full withdrawal, don't do anything at all. And then check balance, respond to the sender with the current amount of funds in the bank account. So nothing too tricky here. We have one int. We can increase it, we can decrease it, and we can respond, this is what the number currently is. How do we test it? Let's go. This text spam would make me blind. I was already blind, so. Oh, you mean the slide? Yeah. The lecture questions. These are the one slides where I'll just pack the information in there, because this is effectively a handout, an assignment handout. I expect you to look at the lecture question after downloading the slides and look at it on your own device. I don't expect you to just look at this as I'm presenting it. Like, this isn't a presentation slide, if that's what you're talking about. The lecture question slides are never meant to be presentation slides. But I do like putting the lecture question on a slide because it keeps me honest. If I have a question that I can't fit on a slide, then that's too much for a lecture question. And this one's pushing the boundaries, but only because I have to define all these case classes and case objects. If I could use significantly fewer words, do a bank account that can do deposits and withdrawals and check the balance. But I have to be very specific so you know exactly what to name everything. So let's talk about how to test these things. So to start, we need to take a little bit of a detour. We're going to talk about traits and mix-ins, just because the testing library is going to use these. So let's at least get the groundwork of what these are, fill in this gap, and then we can move forward. So we've seen abstract classes and inheritance using abstract classes. The problem that we'll face is that when we have a class that needs to extend multiple objects, or multiple classes, sorry. So we want to extend multiple classes, and how would we do this? We can do extends and then a class to extend, but how do we do two? And the answer is we can't. So if we wanted to say have a physical object that also is an actor, we have to extend actor, we have to extend physical object. We can't extend both of those. Not allowed. Can't do it. And so we can get around this in some ways. We can extend actor and then have an instance variable or state variable of type physics object, and then pass a reference to that physics object whenever we need to have physics applied. And as long as we're careful about our reference passing, we can get the job done. But that's not exactly what we want. It's not. It's a little bit of an abuse of OOP. So for this, we're going to use traits and mix-ins. Traits are like abstract classes, except they cannot have a constructor. That's the big difference. Can't have a constructor with a trait. And we use the same syntax as we did for class. Trait, database, define some methods, and that's it. Just can't have a constructor. If we have a constructor, we're wrong. We'll get errors. It'll say, you have a trait with a constructor. What are you doing? That's not what traits are. And now with traits, we can extend any number of traits. Where we can only extend one class, we can extend many traits, as many as we want, using the keyword with. So since database is a trait, we can either extend it, we could just extend database, or if we want multiple inheritance, we're going to create a class, extend just one, whatever class we want to extend. If we just want to extend a trait, we would just say extends database. If we want this to be an actor and a database, we'll extend actor, because actor is not a trait. We have to extend that one. And then use the keyword with, and then a comma-separated list of all our mix-ins. In this case, just one, so no commas. And with all of our mix-ins. As long as all the mix-ins are traits, we'll get all of the behavior of all of the classes that we're extending and mixing in. So we get all of that functionality, but we can only extend one constructor. So only one class that has a constructor. Actually, now that I say it, actor might be a trait. It's possible. But if you're just extending two traits, just pick one of them for the extends and with all the other ones. Yeah, it depends if actor's a... You know what? Let me look it up real quick. You know what? I think my desktop restarted. I think that's my problem. That's why nothing's where I want it to be. I don't want to wait for this to start up. But I want that open anyway, so... But if actor is a trait, then the order doesn't matter. If you're extending multiple traits and they have the same method header, then you're going to have to be worrying about the order. Which one do you inherit? This looks super confusing. I feel like you say that each lecture, Trino. This one, so I'll comfort you a bit. The traits and mixins, I cover them because you're going to see them used, and I don't want them to look super scary to you. But you're not expected to write a trait. I will never say write a trait that does this, and I'll never say write a class that extends this with these mixins. I just don't ask you to do that this semester. But I want you to be aware of what those things are, because I'm about to show you code that uses them. I just don't want you to be like, what the hell is that? So that's the only reason I say that. Or else I would spend a lot more than 2 slides on that topic if I was expecting you to write them and use them. So let's test some actors. For this, we could try to just use FunSuite like we've been doing all semester and write some unit tests. We're gonna see the shortcomings of this real quick. We're not even gonna try, in fact, but I want to explain why we have to use a different library. If we used FunSuite, we would create a unit test, create our actor system, add actors to the system, send messages to those actors, and then have all our certs. And the code is going to run sequentially. It's going to run all this code, send the messages, have the asserts, and we're probably going to execute those asserts before these messages ever arrive at the actors. These messages have to go in the system has to process them, get to the right actor, give that actor a thread to work on, whereas our unit test just has to go to the next line and evaluate a Boolean expression and check whether it's true or false. The assert's probably going to execute before any messages are received. So how are we testing an actor system when our FunSuite is just ripping through this code like nothing? We need some form of time. We need to wait for messages to resolve. And we can't really do that with a FunSuite. We can try using thread.sleep, which just tells that whole thread to not do anything for a while the actor threads can still do their work, and then check. But we're going to hit the next issue is that the FunSuite cannot receive messages. So if we send messages to actors, we have no way of knowing if those actors did what they were supposed to do, because those actors can't respond to us. We can never receive a message. So we created the system, created actors, and let them do their thing. But we have no way of getting information from those actors in the FunSuite, into this unit test. We just can't communicate with the actor system. So this is a big problem. Where do we put our asserts? Do we put asserts in the actors? Well, what if the actors never receive the messages and don't do anything? None of these asserts execute. And if none of the asserts execute, then none of them have failed, and the test is going to pass. So we're really in a jam here. We need something. We need something more sophisticated here. Will it make the homework easier if we use traits? No. I mean, unless that's how you want to design your solution. I don't see a way where it's really going to help. Unless you have a very specific design that could use it. So let's pull in a library that's going to fix these problems for us. In a library that's designed to test actors. The ECA test kit comes from the same library that we're getting our actors from, but we do have to import it separately. So we're going to import the test kit and just make sure your versions match so you know that they're compatible. If you just take the pom.xml from my examples repo, you don't have to think about the versions matching or anything because, of course, I already have them matching. So we're going to import, tell Maven, download this library, link it to my project and everything. We can use this library. And now let's see a test, which is going to test the lecture question from Monday. So if you want to use this to test your Monday's lecture question, if you're still working on that one, feel free to use this testing. So with this library, let's go through this setup of a test. And this is one case where I'm going to say, just cut and paste this code to start each one of your tests. In fact, this is pretty much identical from the documentation of the test kit. Of this test kit library. So if I'm taking the documentation code, I'm not going to tell you you can't do it either. This is pretty cookie cutter. There's nothing to really change here. There's nothing I can do to improve or weaken this. This is just how you set up a test kit test suite. So let's go through this, and just so at least you know what is going on here. First, we're going to import all the classes and objects that we're going to need, that we're going to use. And the one thing that I want to highlight here is this scala.concurrent.duration, and then import everything from that duration package. This is very important. We're going to use some syntax in our tests that rely on this package. And if you use that syntax without this import line, you will get errors. And the errors won't say, hey, your error is that you didn't import the duration package. The error is just going to say, I don't know what to do. So when you get that error, make sure you're remembering this line. And sometimes IntelliJ will auto clean up your imports. So if you don't use any classes or objects from this package anymore, sometimes IntelliJ will just delete that line, that import. And then when you add in this .millis is what we're going to use. You add in .millis again after deleting it. You might get an error because this line, this import was auto removed. So making sure that's there. This will probably be one of the big questions in office hours. Why am I getting errors here? And I'm going to say, where's your duration package import? And you'll say, oh yeah, I remember that from lecture that I diligently watched. And then you'll get that line, and it'll be an easy question to answer. So make sure that's there, or you will get errors. If you're getting errors on your millis, duration package import, you should be thinking. Next, we're going to create the class, the test suite that we're going to create. I'm going to name it whatever, test actors in this case. And we're going to extend the test kit class, which is from the library. And the test kit class has a constructor that takes an actor system. In this case, we're going to create the actor system right in. There's really no other place for us to create this. We're going to create the actor system right in the constructor itself. So where before we would create an actor system, store it in a variable or value. I named it system, store it in a value, and then start working with that actor system. Here we're just going to create it right in the constructor call, and then give it whatever name you want. It can be any name. Just choose some string to name your actor system. And to be honest, the string that you name it isn't too important because I haven't found a way where I see that. I think only if you have multiple actor systems, the name would really matter. So just give it some name. I usually name it whatever I'm testing. I'm testing the string actor, test string actor. Next is all the mixins that we talked about. So this class is going to extend test kit. So this is a test kit. But we also want to get a lot of functionality from other classes to be able to set these up in a kind of appealing way. So we're going to add these 4 mixins. And sorry, I said that was a comma-separated list. I guess it's with. I thought you could do a comma-separated list, but syntax, not too important here. This one works, so we'll do multiple widths. Implicit sender, word spec-like, matchers, before and after all. Most of these are actually from Scala test itself, not from the test kit. The ACA test kit. So these are things that we could have been using all along, but I don't want to throw that all at you on week 3 of the course, talking about mixins and all that stuff. So, but we're going to use the full power. We're going to use all this stuff. We're going to override an after all method. This comes from before and after all. We inherited from before and after all an after all and of course a before all method that do nothing. So by default, this is just open brace, close brace. And that's so we don't have to implement it. We don't always have to implement it, but if we do want different behavior, if we do want some after all behavior, we're going to override that default behavior of nothing and do whatever we want to do. After all is going to be called, as the name implies, after all of the tests are executed. So after all the tests are done, this is going to be called. And as you guessed, if you want to override before all, that's going to be called before all of the tests are executed. Before any tests, you run before all, after all the tests, after all. So this is where we would do some setup in before all, and then some cleanup in after all. The cleanup that we want to do in this case is shutting down our actor system so it doesn't run forever. An actor system doesn't stop until we tell it to stop. It's running on multiple threads. There's all kinds of execution going on out there. So we can't just close the program once we hit the closing brace of our main method, because there's deep in this system, in the implementation of the actor system, we go in an infinite loop and just keep waiting and letting the system run forever. Since the system's running forever, we have to have a way of shutting it down, and we do that by shutting down the actor system like this. So once we shut it down, then our test can officially stop and not just run forever. Otherwise, your test is going to hang. It's never going to pass. It's never going to fail. It's just going to execute forever. So we want to make sure we're shutting down the actor system appropriately. I think if you don't have this, I believe things might still work, but it's not what we should be doing for what it's worth. I haven't tested taking this out, but I mean, just put it in there. Especially if you're just cut and pasting this from my repo, there's no reason to delete this. I don't think I ever have tried it without this. And finally, we can get to our actual tests. So here's where we use our other mixins. And this is kind of a lot of work just to get this, what we call behavioral testing syntax and setup. Is that we have a test name, and then the name for each test. Oh, that's weird. Weird way of explaining it. But we want this to read like a sentence for behavioral testing. So we have a more English description of what we're testing. So we're saying a string actor must track a string in this test case. And then we can have multiple test cases. If we have another set of braces right here, right after this, we can give another string in and give another test case, all in this same top level test. So this is where the other mixins come in. What the library is doing is actually creating a wrapper class for the string class. So this isn't actually a string in this code. It kind of is, but it's a separate class with more functionality, which adds the must and in methods. These must and in methods are called inline. They're methods that take a single parameter, so we can call them inline, and call these methods on some code block in this case. All that just to get more human readable syntax. So creating wrapper classes for strings, adding methods to the string class itself, etc. We're doing all that just to get this syntax where we can have this read like a behavioral test. What should this thing do in these tests? Instead of a unit test where we just have a test name and then run the code, have some asserts, etc. Do video games do this? If you're talking about the infinite loop I was talking about, yeah, they sure do. The games will have usually a few different loops running infinitely, and then reacting to user inputs and just doing their thing until you close the game. Same with any software. Your software usually doesn't close until you tell it to close. So somewhere in there's an infinite loop of sorts that's just constantly checking for user input. It's saying, did the user click? Did the user hit a key on the keyboard? And just constantly checking over and over again. All right, so here's the setup. Again, I want to go through this just so I'm not throwing things at you and saying, just believe me, this works. So that's what this is all doing. But now let's actually write a test, because this is cut and paste, this is boilerplate. Now let's actually write a test. This is the stuff that you will have to do. So once we start writing a test, we want to set up our actors, send our actors messages, control timing. Oh, I forgot. I updated every one of these except the first one. So the very first one is wrong, but it still usually works, but it shouldn't be relied on. So now we want to send the messages, control time, and check if we're getting the messages that we expect to be getting. And the test suite sets all this stuff, the library sets all this stuff up for us. So we have access to the system. This is the system that we created in the constructor of the test kit. The test kit is doing its magic with this thing, but still allowing us to control the system. We did the same thing, and after all, this system is the variable that's storing this system that we gave to the constructor of the test kit. This is an instance variable of, or a state variable of the test kit class. So it's legal to say this.system. It is part of the test actors class now because we inherited it from test kit. So we can say this.system. This is a state variable in this class that we get to take advantage of now. So since we have access to the system, we can say system actor of props, just like we did in the last lecture, to add actors to the system that we're using for testing. So I'm going to create a string actor. I'm going to initialize it with the string hello and add it to this actor system. Same syntax we saw last time. And again, valid syntax if I said this.system. This is an instance variable of this class. I keep saying instance variable now. I forget. I try to stay consistent and call them state variables throughout the semester, but instance variables, fields, I'm blanking on the other names, but they have a lot of different names. State variable, this.system, perfectly valid. And that's why IntelliJ is highlighting it in purple or magenta, I guess, and giving it italics. That means, hey, this is a state variable, just to help us developers keep track of what type of variable each one is. But this.system is perfectly valid here. So we add this actor to the system, and we grab a reference to it, so we can send this actor messages. And I'm gonna, yeah, and this is the code that we should be looking at. Come to think of it, I don't know if I updated it in the repo either. So we're going to send this actor messages, again, like we did on Monday. We're gonna send the append message, 2 messages of type append with different strings that we're going to append to the end of the string that it contains. So for your lecture question, you had to write a string actor class that in its constructor took a string that it initializes at, and each time it receives the append message, append this to the end of that string that it's building. Keep appending to it each time it has append. And when it receives the get value message, responds with a value message containing the string that has been created through all of the appends and the constructor call. So that was your lecture question on Monday, which I'm sure you're all done with, right? I'm sure everybody in the class is done with that one, right? But this is kind of on purpose, where I know most of you are not done with that question, so you can use this testing to help you write that question. If you take this test and use this to test your Monday lecture question as you're writing it, it's going to make it a little easier. Everyone in class equals students watching lecture. Well, we're not quite that bad. And we had that conversation about YouTube views last time on Monday. The view counts are pretty high, so I was happy. I usually don't look at it because I don't want to get all depressed and stuff. Like, man, nobody's even watching lectures. Then I have to get more aggressive with students in office hours. Like, are you watching the lectures? I did this in lecture. But the numbers were actually pretty high. I know a lot of those are probably rewatches, but the videos are getting over 100 views. So I think about roughly 140 students are still showing signs of life in the course. And the numbers are adding up to about that. The rest of the students, there's just nothing I can do for them. But the numbers are adding up pretty good. And the mention that the videos, somebody said the videos were getting over 1,000 views. There's only one video with over 1,000, and it's the physics engine helper, the assignment description. The homework assignment videos get way more views than lectures, understandably so. So we're going to send those messages, and here's where some new content comes in. This expect no message. So other than expect no message and expect message type, the rest of this and the assert, the rest of this we've seen on Monday's lecture and his review. This one is a big new thing. Expect no message. We get this from the test kit. So we extended test kit. We get a lot of methods. Expect no message, expect message type being the two that we're using here. We're going to use these methods to do some of our checks. And this expect no message specifically we're going to use to control time. Expect no message is going to wait for this specified time interval, this specified duration, and then move on to the next line. So this, we're going to wait 1/10 of a second and then move on to the next line. If any messages are received, as the name implies, expect no message for this duration. If any messages are received in this time frame, the test fails. The test stops, everything's done, actor system shuts down, and you get a big, hey, this test case failed. You didn't pass all the tests. You didn't pass all the asserts. So we're going to wait for 1/10 of a second and then send the next message, wait another 1/10 of a second, and we're doing this just to make sure that the messages arrive in the appropriate order. We want to make sure this message is received before this message. We can, in this case, I was getting away without having this expect no message in the middle, but really we should have this to make sure that they're arriving in the appropriate order. So we're going to send a message, wait, send a message, wait, and now we know which order they're going to appear in. We expect them to be in a very specific order. It starts with hello, appends CSE, appends 116, and then wait again, wait another 1/10 of a second just to make sure that this message was received and processed before we send get value. Oh, Twitch. I don't watch I haven't checked the Twitch VOD view counts, actually. I was checking the YouTube ones. And I think YouTube does duplicate. If you watch a video 5 times, I think that counts as 5 views. I learned how to control time. It's alright. That's what we're doing here. So we wait 100 milliseconds. 1,000 milliseconds is 1 second. So I'm waiting 1/10 of a second. If we receive a message during that time, the test fails. If we wait that time and no message was received, move on to the next line of the test. So this is our main way of waiting. This is going to stall our program and make sure that we can get everything in the appropriate time frames. And for your clicker code, when you want to wait like a full second to make sure you get the appropriate idle income, expect no message for 1,000 millis. 1,000 milliseconds later, you're going to move on to the next line, send your messages, and expect there to be a full second of idle income received. So now, this we could do with a unit test. We could do this already. We could, instead of expect no message, we would do thread.sleep for 1,000 milliseconds or 100 milliseconds. We could get that same behavior. The one big thing that we gain by using this library is that we can receive messages. So we can send a message to an actor. This get value expects a response. When string actor gets a get value, it's going to respond with a value. And this library, this test kit, allows us to receive messages in the testing. So I'm going to send the value actor this get value message. And I'm going to expect a message in return. So we have this expect message type, takes the type of message that we expect, and a maximum amount of time to wait for a message of that type to be received. So we send get value, and immediately after, the very next thing we need to be doing is expecting that response message. So we're expecting a message of type value, expect message of type value. The naming is pretty good here. When we give a time here, this is a maximum amount of time to wait. As long as we receive a message of type value within 1 second, then we're going to receive that message. This will be satisfied, and we'll store that in this value named value of type value. Go figure. So we're going to store it and then move on. If we don't receive a message within a second, this will fail. This expect message type and expect no message will fail your tests. They have control over the asserts. Like, we only have one assert here, but we're actually asserting a lot of things internally in each one of these. So if we don't receive a value message within a second, fails. If we receive a message of any type other than value within a second, test fails. So we have to get a message of type value, and it has to arrive within 1 second, or else this test will fail. Yeah, I don't have to have this. I don't have to declare the type here. I usually like adding these just to make sure everything's super clear. So, and this is a maximum amount of time to wait. I'm going to say that probably a few more times. If a message of type value is received sooner than 1 second, we move on to the next line of code immediately. So for example, if I had this for my code, we're not sitting here and waiting for 11 and a half days, as this math resolves to. This many milliseconds is about 11 and a half days-ish. We're not waiting 11 and a half days. We're just waiting until we receive a message of type value. If we never receive a message of type value or any other message, yeah, this will sit here for 11 and a half days. So we don't want very large maximum times here. We want it to be more reasonable, like 1 second. If we didn't receive a message of type value in 1 second, we're not receiving a message of type value. There's no way the actor system and the actor is going to take a full second to respond. So a second is a comfortable amount of time, but we're not always waiting a full second. We do not wait the full duration unless the test fails. The only time this duration matters is if the test fails and we're not moving on with the program. This get value, it's going to be sent. We're going to get value back in just a couple of milliseconds and then move on. So only a few milliseconds is going to pass on this line if everything's working properly. This is important for your clicker assignment when you're expecting a message type and maybe you give it 5 seconds to wait, which it's safe to just stick with the second each time. But say you give it 5 seconds, you're probably getting the answer within just a couple of milliseconds. So after that test, do not expect 5 seconds of idle income to have accumulated, because you're not sitting there waiting on expect message type. We're not waiting this whole duration. Expect no message, we are waiting. Expect message type, we are not waiting. We're just waiting until we get the message, and then we're moving on right away. It's going to feel almost immediate. Expect no message, we are waiting, because we're saying wait for this amount of time and make sure no messages are received in that amount of time. So this we use to control time. This we use just to say, hey, I'm expecting a message. When it gets here, just run this and keep moving on with the program. So there's a big distinction there. I want to make sure that's super clear. I've gotten that question in office hours many, many times. I want to make sure I don't get it as many times this semester. So when we get the message, a message is received. We store it in a value here. Now we can do our asserts and make sure that message contains whatever we expect it to contain. In this case, we expect it to contain hello CSE 116. Started as hello, appended space CSE, appended 116. We should get hello CSE 116 in there. When we do this comparison, for this specific lecture question, and for many of the lecture questions, for a lot of these, I do the same thing. Only for the clicker assignment, I declare the variable names. But for these lecture questions, I don't give you the names. Intentionally, I don't give you the names of the variables inside the case classes. So for this one, I said, make a case class named append that takes a string in its constructor. Very carefully worded to make sure I don't say, make a case class named append that takes a string named to append in its constructor. I don't name that variable in the question. Therefore, you can't use that variable name in your testing, which of course comes into play today, the first time that you're writing tests for actors. So that doesn't have a name. So we can't say assert value dot to append equals, or value dot the current string is equals hello CSE 116. We can't do that. I should have said for value. The name for append doesn't matter for testing. But for value, I didn't say what that string's name should be, that variable should be. So we can't do value dot anything because it's not part of the spec. It's not part of the question. And I know this is a feature throughout the semester because this is going to be a feature, out there in the world. If something's not defined in the spec, you can't test it. If you're writing tests for somebody else's code, especially, you can only test the spec. You can't test the internal workings. The developer themselves can test the internal workings, and you can always have more testing than what's required to test your internal workings. But the tests that I'm expecting has to follow the spec exactly, and only the spec. So how do we get around this? We're going to create a new value with the expected string, and then check if they're equal. So I never said value dot whatever. I just said, is value equal to a new object of type value with this string as its value? And now remember that these case classes are not checked by reference. So this equality is not going to be by reference like we would expect if this were a regular class. Since it's a case class, this comparison is going to be by the values of its variables. So we have a variable of type string. This contains a variable of type string. And the equality is going to compare those two strings for equality and resolve to true if they're the same and false otherwise. So we're taking advantage of that feature of case classes. And if you're not doing this, we're probably going to choose different names for our string, our variable of type string in the value class, case class. So if you are accessing that value directly, it's going to be an error in Autolab. You'll get the slanted faces and the concerned faces, and it's just going to say error. And that's going to be why if you access that variable, because I probably didn't name it the same thing that you named it. For this one, obviously I'm not testing your test for this question, but for today's lecture question I am. So make sure you're not naming those variables. So for each one of these variables, deposit, withdraw, and balance, they all have an int as a variable, but I never tell you what to name that int. So in your tests, you can't access that int. Any of these ints can't be accessed, specifically the balance. You can't receive a message of type balance and say, hey, balance dot whatever your number is, make sure you're equal to whatever. No, you have to create a new balance with the expected value and check if that equals the balance that you received as a message from the actor. We've reached the end of the slides. Any of y'all have questions? I was watching chat because I knew I had some extra time, and then y'all got pretty quiet at the end. Is this a complete test suite? Yep, this is, though, not this alone, but that what we saw at the end would go in here. This green box, that's where all of this code goes. So I expanded it with the actual test, just so I didn't have to have the whole, all of this boilerplate. I didn't want that on all my slides moving forward. But if you have all this boilerplate and replace this box with this, then that's a full, complete test suite that's ready to test Monday's lecture question. And it's very similar to the test that I have in Autolab, by the way. Today's lecture question demo, let's go. I mean, I can't really give it away, but you get you're doing similar things. You're going to create a bank actor, give it deposits, give it withdrawal messages, making sure you're waiting between each message if the order matters, and then sending the check balance message, expecting a message of type balance, and then making sure that balance is what you expect. So I feel like it's pretty straightforward from the lecture. There's a lot of new concepts in the lecture, so it might take you a little while to get your head around what all just happened in the past 45 minutes. But once you do understand those concepts, I feel like today's lecture example, on purpose of course, today's lecture example is pretty close to what I'm asking you to do in the lecture question. So it might take a little bit of time to digest what the lecture is, but once you get there, I don't think I have to demo the lecture question as well. Like if I go a step further, I'm basically just giving away the answer. I got pretty close to giving it away by this setup. And I'll do that more this week and next week because these are much oh my goodness. Much slipperier. That's not a word, is it? These concepts are more slippery. They're a lot harder to wrap your head around and get there. So I'm not gonna hammer you and just say you have to have a deep understanding of event-based architectures before you leave 116. This is more of an intro to a topic where something like functional programming, OOP, data structures, I got to go pretty far. I got to go pretty deep into those because those are pretty core 116 topics. And of course, data structures, I'm laying the foundation for 250. These topics, they're not, they're important still, but they're not as fundamental as the other topics. I can just do a surface level skim of these. It still take 2 weeks, which actually next semester I want to cut this down to 1 week. That's how I'm going to move to 4 learning objectives next semester. I'm going to pretend this isn't a learning objective. Get rid of LO5, turn it into 1 week, and slap it on the end of functional programming. And then downplay it a bit. Trying to change your maze velocity to a state pattern? Awesome. I don't know how that applies to the velocity, but if you see a way to do that, go for it. That's one thing I'm kind of sad about. I want to rework things so the state pattern has some flashbacks later on in the semester. I show it, I show off the uses of it and stuff, and then I don't have a good flashback to it. I get an error when I try to call append. Well, append's not a method. I don't know what you mean by that. Joe Mama, is that your name? Joe Mama. I don't know what you mean by when you try to call append. This right here. Is it because... Oh, right. Yeah, you can't just cut and paste. I see what you mean. Yeah, you can't just cut and paste because I don't have the rest of the imports. You have to import your actors package. So you have to import... Yeah, this isn't a full one. You have to import string actor, and you have to import append and get value and value. Oh, my import. So yeah, you can't just blatantly cut and paste these. Because I don't have import actor dot underscore would be fine. Super tired and having trouble following along. Get some sleep, man. That's one of the most common pieces of advice I give. If you're too tired to follow a lecture or something, it's in some cases you're just wasting your time. Just take a nap, wake up fresh, and then hit it. It can seem counterintuitive, like I need to be constantly getting something done, and if I'm sleeping, I'm not getting anything done. But you'll be more productive after you wake up, that it can even out. But really, just getting more sleep at night is the more important thing. Managing time. It's tough to do. I still pull all-nighters every once in a while. But you're so much more productive when you're well rested. We have multiple tests. Yeah. So you would have... So this is a test, and you would just do this again. Actually, it's time to go to the code, ain't it? That one. This one. We're back set up. So you can cut and paste this. and have multiple tests like that. Oh yeah, I didn't even put that string code in the repo, did I? Yeah. Yeah. Talking about labs and like in office hours, you can always ask about labs. No, we're not going to answer questions about lab on Thursdays during the lab, but like after the lab, and you want to be like, I really didn't understand Q3 on the lab. And you remember what Q3 is because there's different versions of the labs, and we're not going to know off the top of our heads. But you can either be patient while we look it up, or be ready. Like the question said this, I didn't understand this part of the question. Yeah, we'll answer questions about labs after the fact. We'll answer questions. Could you just demo anything? Hey, I guess this counted, right? So with this one, I had the value actor. This, I guess I haven't talked about this one in lecture. This was the old lecture question. I changed it to appending strings. It was the same idea. Increase instead of append. Get value and respond with the value. Of course, I'm giving away the answer to the lecture question. Well, now I did demo Monday's question. You just change int to string. But so to test this, I didn't even demo it. It's in the damn repo. Whoops. oh well. So I initialized it to 10, sent increase 2 times. This is where I didn't have my millis in between. Like this we had with the concatenation because the order does matter. Here the order doesn't matter. That's why I had it set up like this initially. I expect it to be 20 no matter which order these identical messages arrive in. I'm going to send get value. Expect a message of type of 100 back. Of type value. Of type value. And I'm going to wait a max of 1,000 milliseconds. So I ran this, it passes, I get the value 20. But if I go to the value actor and say I don't send the message back, we're going to sit on this and wait for a full second. And then the test is going to fail. And let me get just one test here. If I change this to 10 seconds and run it, we're going to sit here and wait for 10 full seconds waiting for a message of type value, which is never going to arrive because I removed that from the code. But we're going to wait for 10 full seconds to get that message. And then once we realize, hey, this message is never coming in, we're going to get the error. It's going to say, we waited 10 seconds, didn't get a message, your test fails. If we add this back in, but leave this at 10 seconds, hell, we can even change it to 100 seconds. Oh, I'm not even on the right. Dang it. That's why I have to be on live chat. I'm not on the right screen. Damn it. All right, let me get back to that in a second, but let me catch up on chat then. I love FP. 1/16 split between 2 sections next semester. That is accurate. With 2 different instructors. Yeah, the TA might not have the doc handy with those. We don't all review the labs. Every TA doesn't review the labs. So only a few TAs are responsible for the labs. But if you're super patient, they can pull up the doc. But it would take a while. If they have a long queue, they might just say, I wouldn't blame them if they just said, you know what, no. If you come to my office hours, I'll pull up the doc because I have them really handy. I just got to brush up. I know what the questions are. I just got to brush up on them. All-nighters, where you're working all night. I haven't pulled a true all-nighter in a long time, but sometimes I won't get to bed till like 4 in the morning. And the next day, I'll try to find a spot where I can take a quick nap. Even if I take like a 10-minute nap, I'll feel a lot better after. Won't you get fired from the work? Oh, if you take a nap during work, wouldn't you get fired? No. No. If you're taking naps like for a few hours every day during work, maybe, but employers are going to understand that programming is it's a very mentally intense job that usually what I like to do is if I'm working, when I'm working like 8-hour block of time with just lunch in between, I'll just go for a walk every once in a while. No one's going to get mad at you for that, as long as you're still getting your work done. You can't just sit down and code for 8 hours straight with just a lunch break. It doesn't work. Can we ask TA what velocity is if we still don't get that? I mean, yeah. You can always ask anything, whether they're going to answer you or whether I'm going to answer you. You might not get the answer you want, but if you're asking about velocity, I thought I went over the whole thing. I mean, I went over a little bit more than me or the TA should in an office hour setting. The only reason I can get away with that in lecture is because it's a fair game. I'm giving it to everybody, so that's fair. But if we give it to one student in in a office hour setting, that wouldn't be appropriate to say that what I said at the beginning of lecture. So I already crossed the line. You're not getting more than that. You got to figure it out at that point for the velocity. Go watch and I cut the stream so that won't make it to YouTube, but check the VOD, the one that says 442. It's if anyone who's paying attention to the lecture gets that hint. No lab this week? There's lab. There's definitely lab this week. It's lab every week. It might be a makeup lab. I actually forget. Can't believe I was on the wrong IntelliJ. No. Yeah, there's a big lab this week. It's L4 verification. Tomorrow, yeah. And clicker demo's not till forever. No, Manga Mutiny. No, it's right here. Learning objective verification. Data structures and algorithms. And the interview will be an interview about data structures and algorithms. It's a learning objective verification week. There's lab and interview. Very important lab and interview. Don't be skipping anything this week. Go into more detail about what that case does. Yeah, well, I'll get to the right IntelliJ once I get to live chat. And I'll give a demo of that. How many seconds until he notices? Too many seconds. Okay. So this is the one that it was showing, because it opened up two windows when I opened IntelliJ. Was the problem. So when I went to put IntelliJ on OBS, it's like, oh yeah, I see an IntelliJ. I'm going to pull up this one. Okay, now we can see the right thing. We can see this. And we have this value actor. This was the old lecture question for the Monday, the first, the LQ 5-1. Where we have an int that we initialize at. Whenever we get the increase message, we're going to increment the int by that much. And whenever we get the get value message, we respond with value. This should be very similar to Monday's lecture question, except I changed it to use strings instead of ints. So the test for this, let me put this back. So the test for this, we're going to create the actor with the value 10. We're going to increase it by 5 twice. Wait a tenth of a second to make sure these messages resolve. Send the get value message. Expect a message returned of type value. Wait a max of 1 second. Then make sure the value is 20. So we run this. So we run this thing, and we expect this to pass because my code's right, so everything works fine. We got green check mark, we're happy. Now, if we change this code, so when I get the message of get value, let's... Wait, what? Okay. When we get a message of type get value, let's not respond with our value. Let's not do anything there. Now when we run our test, when we get to this line, we're going to wait for 1 second. After a second passes and we don't get the value of message, we're going to fail that test. So let's increase this to 10 seconds. Do the same thing. Now we're going to stall right here for 10 full seconds, waiting for that message of type value. And after 10 seconds pass, this test is going to fail because we waited 10 seconds for a message of type value. We didn't get one. We're never going to get one because it doesn't send. None of us can. RT Keenan, quiet you. I can see it now. I just wasn't looking at OBS on the last one. That's why I missed that. And we get our message that says, hey, I waited 10 seconds, didn't get a message of type value. Fix your code. Your code's broken. But importantly here, once we do fix this, and of course that took a while for this message to come up, 10 seconds. If we do fix this, but leave our testing code at 10 seconds, we're not waiting 10 seconds. We can crank this up to some ridiculous amount of waiting time. We're not waiting this much time. We waited almost no time. The entire test took 161 milliseconds. 100 of that was sitting right here. And then 61 milliseconds of overhead just processing everything, setting up the actor system, doing everything that it needed to do, setting up the test suite, all that stuff. So 61 seconds of overhead. We did not wait this much time at all because we got the message. As soon as we got the message, we moved on with the code. If we add to an expect no message, we are actually waiting that amount of time. If we change this to 10 seconds, we are actually waiting 10 full seconds right here. We're sitting on this line, 10 seconds. And then finally moving on to the next line. And this we expect to pass, but we had to wait 10 seconds stalling right here, and then 66 milliseconds of overhead of setting up the test suite and all that. So expect no message always waits this long, except I shouldn't say always. If we send a get value message, now we're going to get a value message in response, and this is going to fail. So this fails because we were expecting no message, but we did get a message of value of 20. Received unexpected message, value of 20. That's no good. Even if we do this back down, let's put our numbers back to reasonable. Since we did get a message while we were expecting no messages to be received, we're going to fail this test. Received unexpected message. But we get rid of this. We can have a few of these. Maybe we want to wait a couple of times, make sure everything's processed in exactly the right order. Be really safe about everything. And we green bar. And let's say we break this. Maybe we don't do anything when we receive an increase. Now we expect this assert to fail. expected actual. And these values, I chose just I for these variable names. If in my, just to emphasize what I'm talking about with naming these variables, I just happen to name these I, and I, especially for value, I name this I. So in my assert, what I could be tempted to do is say value.I equals 20. I'm going to run this. Everything's going to be fine. But I submit this to Autolab, and I might not be fine. So, for example, I named it I. I probably have, for this, when I ran this lecture question, I probably named those variables I in Autolab. And I'm running your tests, if I'm running your tests against my solutions, and I name my variable I, and maybe you named your variable trying to think of something more creative, but let's just say you named it value. That looks too weird. Let's just say number. Let's say you named it number. And when you test your code and your value actor, your value message, you named it number, everything's fine, no errors, everything's cool. But when I run your test against my code and that variable is named I, you get this error. And this is the same error that Autolab's going to see. It's going to say, there's nothing named number. I can try to run this. It's not going to compile. It's just going to be broken. That's when you get the error in Autolab. Error running your test against correct solution is what you're going to see in Autolab, because you're using number, but number doesn't exist. It doesn't exist in my code anywhere when I'm running it against my correct solution, which named it I, running your test, which named that number. Number doesn't exist. Error in Autolab while running your tests. When we have to know this to pass 90% of the lecture questions? Yes. I repeat this a lot throughout the semester. Yes, absolutely. Anytime a name is not defined in a lecture question, you can't use it. I've been saying that all semester, so hopefully everybody knows. But it is one of those common errors. I like to say it early and often to make sure that everybody knows it. Anybody who's paying any attention at all to this course knows when you can and can't use a variable name in your tests. So then when I get that question office hours, I can be like, well, you skipped half the lectures. But I want to make sure everybody sees exactly why that's the case, and hopefully anyone who's trying it all doesn't make that mistake. Because when you make that mistake, it's painful. You have, unless you remember exactly me saying that in lecture, or early on I put it in the lecture questions themselves to make sure you know. And if you miss that, it's very frustrating. I've seen a lot of students get completely demoralized really early in the semester because that was the mistake. Because it's no mistake on their part. I mean, I'd argue that it is, but it's not a mistake on their part in terms of their understanding of the material and their ability to produce working code, which is what makes it really frustrating. It's about their ability to, watch the lectures and make sure they don't miss anything. So that's why I like repeating it a lot, because it's just one of them really, really frustrating, very, very frustrating errors. And it comes up, I like re-mentioning it here because it comes up in a different way. We have a different way of addressing that problem in creating a new case object. So it is a little bit different than what we've seen before because there's a workaround.